Hey guys, it's Heap, and today we've got not one, not two, not three, but 5 different devices. This video has got 5 different parts, and it all revolves around SiFive's HiFive Unmatched, the world's most powerful native RISC-V development platform. If you've seen the previous RISC-V video, you'll know that I had a few USB issues, so I decided to upgrade the system. I didn't know what package manager was used, so I decided to find out, and it seems to me like OPKG is the package manager of choice for our Freedom USDK. So I ran OPKG dis-upgrade and it started upgrading or removing files. This is interesting, we'll get back to this later on, but this review is focusing a bit more on the regular user side, who probably develops stuff a little bit but is otherwise not a kernel developer or not a embedded systems developer, because, well, that's who I am. I'm not a kernel developer, and that's the perspective I can give you guys. Now, the devices, I picked them to test against, not only because they're the only ones I have, but also because each of them have a really unique set of pros and cons. For instance, my Ryzen desktop is a beast, but it's big box and it outputs a lot of heat and stuff, and it's a fairly new TSMC design. Meanwhile, my laptop, it's moderately old, it's 4 years, 8th gen Intel, and the M1 iMac theoretically shows what could SiFive achieve today if they went all in and produced a really big chip, because M1 is ARM architecture and it is on TSMC's 5nm. While Raspberry Pi 3 is the latest Raspberry Pi I've got, but it is something very similar. It is an embedded Linux computer, single board computer that, well, you can use as more of a server of sorts, not a day-to-day desktop. And speaking of day-to-day desktop usage, well, obviously a Linux desktop or macOS is going to be the best usable experience. I mean, you've got wobbly windows, everything's butter smooth, you can have 2 SSH windows seeing your RISC-V distribution getting obliterated. You can also have a very smooth browser with YouTube, perfect video playback. For instance, you can turn up 16K and just go with it. Look at this. Beautiful. Oh wait. Okay. 16K may still be off the table, but you can go and watch 4K instead. While the Raspberry Pi, as I said, is more of a mini server type of thing. So where does HiFive Unmatched place itself in terms of these devices? Well, let's finish up the upgrade. Oh wait, it didn't upgrade, instead it obliterated the system. Oh well, it's time to install Ubuntu, so I followed this guide to burn the SD card and basically override the FUSDK because, well, it was obliterated, and boot it up. The first boot took quite a bit of time, like 5 minutes or so, but I believe it needed to resize the SD card and so on. The other boots usually take like, I think, 3 minutes or so, which is quite a bit, and it's an optimization opportunity. To me, and I'm not exactly sure in the details of the boot process, I believe they just don't have any fast paths, any caching or sorts, so they just reinitialize everything on each boot. And it definitely could be improved, because, well, other devices boot in 30 seconds or so. And after installing, I installed GNOME and started GDM, and everything worked just fine, other than this cursor being completely messed up, but after logging in, a correct cursor appeared. I think it's my issue because like hovering over Windows, you see a messed up cursor, but other than that, the desktop functions perfectly fine. Windows move perfectly smooth, everything's fine, and the USB issue, it's still there, sadly, which is a shame really. But I eventually upgraded the kernel to the same version, but like a different version number, and it was better. Like maybe it was a fluke, but it genuinely was better. Instead of stopping after 5 seconds, it would stop after 60 seconds, so it was overall much more usable. And now, well, how was it the experience of the desktop? Like I said, the windows move very smoothly. There is a bit of an issue when you not move the windows, but rather drag and drop on the desktop. It becomes extremely sluggish. I don't know exactly why. I have two theories. One, it's doing that particular part on the software side, which could be a GNOME issue, or second, it's doing a lot of disk I/O for some odd reason, and that could also be a GNOME issue. And also the fact that I'm on an SD card, while ideally you would want to run an NVMe SSD. So while the windows move rather smoothly, I have to say that there is quite a bit of sluggishness to the system. For instance, there are quite occasional lag spikes when you open a new window or when you log in. And when you SSH into the device, tabs, they take a while to compute, which could be explained by the SD card, but it doesn't really explain why the Raspberry Pi is faster, more responsive in that regard. So I think there's quite a bit of software optimization that could take place. Now, as for the software, it gets a bit tricky. For instance, there is no Firefox. There's no unofficial Firefox build available. So we had to use Epiphany, which loads websites very fine, but for instance, YouTube videos, they just don't play. Which is a shame. So I couldn't play YouTube, but how about regular video playback? I copied over one of my videos, which is the Hexforce project, which you should totally check out. I copied it over and it plays perfectly over MPV. There are no stutters, no nothing. It's 4K 60 by the way, so it's playing perfectly. There was one glitch I couldn't get on camera because the SD card ran out of memory, but I couldn't replicate it again, and it fixed itself when I seeked. So it could be MPV issue or VA API. As for hardware decoding and encoding, which is a really important part for video consumption, it works. It genuinely works. I just installed VA info and it showed the RX 580 up. I ran through FFmpeg and it decoded the 4K 60 stream at 120 FPS, which is more than enough. The transcoding though was a bit slower. It ran at 17 FPS, which is not very ideal, but I think that is actually the RX 580 limitation, not the RISC-V's. Because, well, the 580, I don't think it handles 4K officially. 4K encoding streams. And yeah, I mean, everything works on that regard, other than the fact that there is a severe lack of software, which brings us perfectly to the synthetics test. I originally wanted to add a Blender test to render one of my thumbnails to see how it compares, but Blender is not available, and the official builds, like for various RISC-V distributions, they seem to be failing. So I didn't get on to trying to compile them myself because I'm on a rather strict time schedule, but I think it just wouldn't compile because it fails on them. So it's a problem, but for synthetics I decided to keep one test in, and that is Geekbench, because they started to provide RISC-V builds and ARM builds. So, well, I ran them and here are the results. So the 5950X on my desktop, well, it was an absolute beast. It's 1414, 14,236. The i7 is 1167 and 5377. The M1 is really interesting. It's 1725, which is much better than the Ryzen, and the multi-core performance at 7673. Now the Raspberry Pi comes at a very modest 36. And multi-core at 70, which is a abysmally slow. Which leads us to the RISC-V, which is at mere 41 and multi-core performance of 102. Which is a bit disappointing, but if you recall the process technology and the point of this chip, it's okay, because the chip itself is rather small. It's much smaller than the Ryzen I've got, and it's on TSMC 28 nanometer. If SiFive were to move it from 28 to 7 or 5, we could quite easily get 10x density at the same size. So if SiFive were to 10x the density and 2x the chip size, well, you would be looking at over 1,000 single core performance, which would be pretty darn good. And this, you know, it's not meant for mainstream, even though we're looking at from like a regular user's perspective. It's meant for developers. So I think it's pretty good score. So while the synthetic tests were not very comprehensive, although Geekbench does do quite a lot of tests, the compiling and developing things are, well, pretty straightforward. I installed Rust with RustUp and it just worked. I installed Clang and, well, it installed just fine. I could write a hello world program and it was perfectly fine. As for a compile test, I pulled ScanFlow and compiled it on the machine, on all of the machines, and here are the results. My Ryzen 9, it was by far the fastest at just 21 seconds, followed by the M1 at 28.9, the i7 at 45 seconds, and then was the RISC-V machine at 19 minutes and 31 seconds, which is pretty yikes. But if you look at the synthetics test, you can see that while on synthetics the RISC-V machine is over 140 times slower, the compile times are just 55 times slower, which is really interesting because it shows that RISC-V is a much easier architecture to compile code for, mostly driven by the fact that it's a very reduced architecture. And that means there's much less work for the compiler to do. But then final thing is the Raspberry Pi at abysmal 34 minutes and 8 seconds. I'm not exactly sure why it was so slow, but it was rather slow. And maybe it's ARM being a bit more complex and it takes on the thing. Or maybe the compiling is generally multi-threaded. Well, relative to the performance metrics, the compile times on the RISC-V machine are an outlier of sorts, because the Pi is, well, it's 100 times slower, which is pretty comparable to 140 times it's slower. So yeah, here are the compile times, and as for the tooling, everything seems to work, although you won't be able to compile certain Rust things yet, like Rust TLS, because it depends on crypto, which doesn't support RISC-V yet. But other than that, the tooling seems to work just the same way, like Hello World was fine with C, Rust code compiles just fine. It's pretty good overall. Now let's get to the gaming side of things. This is where the same narrative of no software support comes into play. I wanted to do some Java stuff like playing Minecraft, but their reports say it's like unplayable whatsoever. So I instead installed Minetest, which is, well, a Minecraft clone, and it worked just fine. It ran at 16 FPS, which is actually pretty low, because the graphics performance is definitely not the limiting factor here at play. It's CPU limitations. If you look at the machine right here, the laptop, it manages to do 4K 60 no problem on integrated graphics, so it's definitely a CPU limitation. And I couldn't really find any other games to play. I would have tried some x86 games, but Box 86 or Box 64, which is a really awesome emulation project to make x86 programs run on other architectures, well, it currently only supports ARM only, so it was not an option. And it's like perfectly describes the rest of the ecosystem. It's just emerging and the software is just not there yet. We could see from Firefox not being provided, which I'm actually not sure of the reasons, I should check, and Blender just straight up not compiling, and Minecraft and stuff not working out of the box. So the tooling is not there yet, and this is definitely something that could be improved upon. And I think that is kind of the conclusion. Everything is promising, like the hardware from the synthetics, it's promising, the compile times are promising, but the overall sluggishness of the system compared to the Raspberry Pi, it suggests that there is still a lot of room of improvement, especially with the USB issues still persisting. Things are to be improved, and I hope I could work on the USB issue, but sadly no time. But I'm actually excited to have this machine, and I'm excited to see how things progress 3 years down the line of sorts. And if these issues get ironed out, and then eventually we get a much more powerful board, maybe something getting closer to the cutting edge of the SMC or whatever fab becomes the leader then, we could see a really compelling piece of hardware, I believe. And yeah, I'm looking forward to that, and there is not much else to say here, other than we will do quite a few experiments with Manflow. I hope to do rather soonish. But other than that, if you love this video, then overflow the like button and hit subscribe for more content. And thank you very much for watching. Don't forget, my name was Heap, yours was Undefined. See ya.